Something crossed the boundary of our solar system last year, not from the Kuiper Belt, not from the Oort cloud. From somewhere else entirely, light years away, forged under an alien sun we'll never see. For 3 months, it blazed toward ours. And then, at the moment of closest approach, it disappeared behind our star. When it emerged on the other side, it was no longer the same object. Scientists called it C/2024S1 Atlas. But that sterile designation hides one of the most dramatic cosmic transformations ever witnessed. A frozen relic that carried the scars of billions of years in the void, and then tore itself apart in front of our eyes. I'm the ultimate Trex, and what you're about to see will change how you think about the space between stars. July. Astronomers spot something unusual. A fuzzy blob, moving wrong. Too fast. Wrong angle. The Atlas survey flags it immediately. This thing isn't from around here? For 3 months, telescopes around the world track it. Every night it gets brighter. Every week, stranger. Then, in October, as C/2024S1 approaches the sun, scientists brace for the best show of the year. But there's a problem. The sun itself blocks the view, the comet disappears into the solar glare, and Earth goes blind. Before it vanished, though, NASA's Swift Observatory, equipped with ultraviolet eyes that can see what ours cannot, captured something shocking. A flood, a deluge, an absolute torrent of hydroxyl radicals pouring off this object like a broken fire hydrant in space. We're talking 40 kilograms of water per second. Now here's why that's insane. This comet was sitting at 2.9 astronomical units from the sun. That's almost 3 times Earth's distance. Out there, it's freezing. Water ice shouldn't be boiling off in those temperatures. It's like finding an ice cube melting in a freezer. The only explanation? This comet wasn't just shedding water vapor. It was ejecting entire chunks of ice, grains, pebbles, crystals, hurling them into space where they'd shatter and sublimate, multiplying the surface area 1,000-fold. This wasn't a comet. This was a machine designed to destroy itself. While Earth watched empty skies, our deep space sentinels kept vigil. STEREOA, SOHO, GOES-19, solar observatories that stare directly into the sun's corona, unflinching. They watched C/2024S1 make its closest approach. And what they saw was a transformation. The comet's brightness didn't just increase, it exploded. The mathematical relationship between distance and luminosity went from a gentle curve to a cliff face. From an exponent of -3.8 to -7.5. Translation? This thing became 70 times brighter than physics said it should. But brightness was just the beginning. The color started changing. From Earth before the blackout, astronomers saw red, deep rusty red, the signature of dust, of organic compounds baked for eons. Then, briefly, green flickered through. But behind the sun, at perihelion, the observatories captured something else entirely. Blue. Electric, fluorescent, impossible blue. That blue wasn't reflection, it was emission. Carbon monoxide molecules, superheated, screaming in ultraviolet. Amide radicals, fragments of ammonia, glowing like neon signs. The sun had burned it, stripped away the ancient crust like peeling an onion, exposing the volatile core beneath. A frozen engine of pristine ices that hadn't seen starlight in 4 billion years. This was no longer the object that entered our system. This was something new, something raw. February. While the comet raced outward from the sun, it crossed paths with the fourth rock from the sun, Mars. At 0.19 astronomical units, about 28 million kilometers, C/2024S1 made its closest approach to the red planet. And unlike Earth, Mars had front row seats. The Mars Reconnaissance Orbiter's high-rise camera the sharpest eye in the solar system, swiveled to capture the visitor. But bureaucracy intervened. A government shutdown delayed image processing for weeks. When the data finally arrived, scientists saw a blur, a fuzzy blob hiding inside a 1,500-kilometer shroud of gas and dust. But HiRISE wasn't alone. MAVEN, Mars' atmospheric sentinel, captured the invisible, a massive envelope of hydrogen, the fingerprint of water destruction, ballooning around the nucleus. And then there was Perseverance. From Jezero Crater, the rover tilted its cameras toward the Martian twilight and snapped a photograph. A faint smudge against the stars, barely visible, but historic. The first image of an interstellar object ever taken from the surface of another planet. Think about that. A machine we built sitting in the dust of an alien world, photographing a visitor from beyond our sun. 3 worlds, Earth, Mars, and this ancient wanderer, aligned in a moment that will never repeat. But not everyone was satisfied with the natural explanation. As data poured in, a vocal minority began asking uncomfortable questions. Why was there a jet of material pointing toward the sun? Shouldn't comets spray away from the heat? Why was the comet accelerating faster than gravity alone could account for? What was pushing it? And why did its trajectory look so artificial, so straight, so precise? Some researchers, most notably Harvard's Avi Loeb, proposed the unthinkable. Could this be technology? An interstellar probe? A light sail damaged by its journey, tumbling through our system? For months, the debate raged. Press conferences, papers, counterpapers. Then, the evidence arrived. Let's address each anomaly. The sunward jet? It's an illusion. When a comet rotates, sublimation on the sun-facing hemisphere creates a fan-shaped spray. From certain angles, like Earth's, that fan appears edge-on, looking like a spike pointing directly at the sun. Comet Halley does the exact same thing. It's geometry, not propulsion. The acceleration, it's called the rocket effect, and it's been understood since the 1800s. When a comet loses 40 kilograms of material per second, that mass doesn't just vanish, it pushes. Newton's third law, every action has an equal and opposite reaction. The measurements of carbon dioxide and water loss exactly match the observed acceleration. The straight trajectory? Another illusion. All hyperbolic orbits, objects moving faster than escape velocity, look like straight lines when you're inside the system. It's still following Kepler's laws. It's still natural. It's still gravity. But if you wanted proof, undeniable, unambiguous proof, you'd need to see inside the comet itself. South Africa, the Meerkat Radio Telescope Array. 64 dishes, synchronized, staring at the same patch of sky. And they heard it. Not with cameras, not with spectrographs, with radio waves that penetrate dust and gas like X-rays through flesh. 2 frequencies, 1,665 megahertz, 1,667 megahertz, the unmistakable signature of hydroxyl radicals. This wasn't ambiguous. This wasn't indirect. This was the molecular fingerprint of water destruction, measured in real time, quantified down to the density of the gas. C/2024S, 1 Atlas, was soaking wet. Icy, volatile. It was a comet. Nothing more, nothing less. No metal hull, no engines, no alien architects. Case closed. But the real mystery was just beginning. When scientists analyzed the chemical composition, they found something wrong. The ratio of carbon dioxide to water was 7.6 to 1. Standard comets, about 0.12 to 1. This thing was a dry ice bomb wrapped in a thin shell of water ice. So what happened to it? The answer lies in the journey. Billions of years, thousands of light years. drifting through the endless void between stars, bathed in cosmic radiation, galactic cosmic rays that tear through molecules like microscopic bullets. Over eons, those rays broke chemical bonds, rearranged atoms, cooked the surface into something else entirely, a 15 to 20 meter crust of processed, irradiated material. The spectral signature matches carbonaceous chondrites, the most primitive meteorites we know, but with a twist, unusually high concentrations of nickel and iron. And here's where it gets wild. As the sun heated the interior, water began to melt. Not on the surface, inside the crust. That water encountered the metal-rich matrix and triggered Fischer-Tropsch reactions. Catalytic chemistry that releases heat, explosive heat. Pockets of superheated water trapped beneath an irradiated shell, building pressure until, boom, cryovolcanoes, ice eruptions, chunks of the nucleus blasting into space. This comet wasn't just melting, it was self-destructing. Right now, C/2024 S1 Atlas is heading back into the dark, outbound, cooling. The fire hose is shutting off, but its journey through our system isn't quite over. March 16th, 2026, the comet will pass within 0.35 astronomical units of Jupiter, close enough that NASA's Juno spacecraft might get one final look, one last photograph, one last spectrum, one last chance to say goodbye to the visitor from beyond. And then, it's gone, back into the galaxy, back into the silence between stars, carrying with it the scars of its passage through our sun's fire. We may never see it again. But for a few brief months, we shared our solar system with something ancient, something transformed, something that reminded us just how strange and how beautiful the universe really is. If you want to follow the next interstellar visitor, hit that subscribe button, because if there's one thing we've learned, they keep coming, and we'll be watching.